I'm going to be solving the 2009 AMC 10B problem 23. Let's read through the problem. Rachel and Robert run on a circular track. Rachel runs counterclockwise and completes a lap every 90 seconds, and Robert runs clockwise and completes a lap every 80 seconds. Both start from the same line at the same time. At some random time between 10 minutes and 11 minutes after they begin to run, a photographer standing inside the track takes a picture that shows 1/4 of the track centered on the starting line. What is the probability that both Rachel and Robert are in the picture? So, in this problem, we have to find the individual probabilities that Rachel and Robert are in the picture. Then we have to find the intersection and see what that is out of the 1 minute span. So, the time span is 60 seconds because it's between 10 minutes and 11 minutes. And we want to find the intersection, the range time of intersection where both Rachel and Robert are in the frame. So, since the photographer captures 1/4 of the 1/4 of the track, we can first find the probability that Rachel is going to be in the picture. So, the probability that Rachel is going to be in the picture can be determined first by finding out when Rachel is going to exactly reach the starting line. So between 10 and 11 minutes, the moment that Rachel reaches the starting line is at 540 seconds. And this is Rachel reaches starting line. So Rachel's starting line. And over here, we can also write the time span is from 600 seconds to 660. And actually, I made a mistake here because it wouldn't be 540. It would actually be 630. 630 seconds, and this would be after Rachel completes her 7th lap, and because this is between this time frame. So at exactly 630 seconds, or halfway through the photographer's time span from 600 to 660 seconds, Rachel is going to exactly reach the starting line. Now we have to find out from which time to which time is Rachel going to be in the frame. So Rachel is going to be in the frame for 22.5 seconds because 90 seconds per lap, so 1/4 of the track, it's going to take her 22.5 seconds in frame. So 22.5 seconds in frame. And if we're being specific, it's going to be from the 630 seconds, it's going to be before this and it's going to be after this. So if we take half of 22.5, it's going to be 11.25 before. And by before, I mean before the 630 seconds. And it's going to be 11.25 after. So before and after. So to be more specific, by this I mean that at 618.75 seconds to 641.25 seconds, this is when Rachel is going to be in the frame. Now we can do the same calculation for Robert. Robert completes a lap every 80 seconds, so Robert is going to be in the frame for 20 seconds. So let's draw a line. So this was for Rachel. Now this is going to be for Robert. So Robert is going to exactly reach the start line again at the moment that's between 10 and 11 minutes. That's divisible by 80. In this case, it's 640 seconds. So this is when he's going to be exactly in the center of the frame. Now, since Robert is going to be in the frame for 20 seconds, the time that Robert is in the frame is going to be from 630 to 650 seconds because it's 10 seconds before and 10 seconds after. So now we have to find the common time that they're both in the frame. So this is going to be from 630 seconds. So let me draw a line. It's going to be from 630 to 641.25. So this is 11.25 seconds divided by 60 total seconds. 11.25, once again, is the time that they're both in the frame together, and 60 is the total. We can multiply both sides by 100 to get 1125 over 6,000 to make it easier to simplify. Dividing both the numerator and denominator by 25. So dividing the numerator by 25, we get 45. Dividing the denominator by 25, we'll get 240. Dividing both the numerator and denominator by 15, we get 3. And dividing the denominator by 15, we get 16. And so the answer is 3 over 16, which is C.